All right, I can see people taking photographs. There is the Zalando QR code. So our hosts tonight are hiring. So if you're interested in a job at Zalando, and the awesome search team, this barcode, this QR code is for you. Was it good? All right. I would like to welcome our second speaker tonight, David from Flink. And he will speak about building offline agents for online search. I think we announced it a bit in a different way, but I could see that it's related. Okay, so please welcome David.
Hello? Okay. Thank you very much, everyone. Thank you for having me. Yeah, I changed the title. I thought this was a little snappier. So my name is Dave Fennesey. I'm the principal engineer at Flink. Right now, I'm in charge of all of the back-end stuff. So like whether it's consumer facing or operations, but my love has always been search. You can ask my manager. I'm very stubbornly always trying to look into search and how we can improve it with our search team of 1. So we're hiring if you want. But go to Zalando first. I'm going to use this word a lot throughout the presentation, which is golden set or annotated set. So by a show of hands, how many people know what I'm talking about when I talk about a golden set? Okay, about 50%. We got a lot of search people here. I'll bring the other people up to speed really quick. So a golden set is generally how we train search relevance offline. The idea is that you create a mapping of keywords to products and you give each product a judgment. So for example, I would give someone a task to say, go through our catalog and find all of the relevant milk products, and then go through our catalog and find all of the relevant oat milk products. We take all of these judgments and put them into a list. And we typically give this to some poor level 1 category associate because this task sucks. But because everybody has a different opinion, you can't just take one person's golden set and then just run with that in production. You have to merge multiple people's opinions together. It's awful. And especially if, let's say, you add a new product to your catalog, which never happens, don't worry. But the way that we're gonna basically use golden sets is you take what this ideal set is. So you say, like, for this particular query, I expect these products in the top, these products in the middle, and these products should not show up at all. Then you run the query through your search engine, and then you can measure the difference between what the golden set said and your search engine said. By tweaking the search engine, you can basically try and get it as close as you possibly can to the golden set. That's all. The reason why companies might invest in this is because they want to make their search team happy. The reason why they might not invest in this is because it's very time-consuming and tedious to keep up to date. So I'm not actually going to talk about our search pipeline at all, but because this is a search conference, I figure I would tell you what we use at Flink for our search pipeline. We have a 3-phase pipeline, apparently not super rare. We have a pre-query classifier. That pre-query classifier uses a cat boost model. Most of our keywords at Flink solidly map to one category. So someone might search for milk, and we have a category called milk. Someone might search for cheese, we might have a category called cheese. So we will run these searches through the classifier. The classifier will output the category that it believes is the most likely add to cart that will follow. So like, okay, when someone searches for milk, most of the products they will ultimately click on are in the fresh milk category. Therefore, that one has the highest rank. We then take these boosts and we go to the retrieval phase. The retrieval phase is just a simple BM25 Elasticsearch thing. And for anybody who's run Elasticsearch at scale, you know that getting single word queries is oh so fun because you have no context of what they're talking about. So if someone searches for milk, you have no idea if they're searching for oat milk, fresh milk, milk chocolate. It all looks the same to a BM25 index. So by taking the boosts from the first phase and multiplying them into the BM25, we can effectively push the relevant categories up a little bit higher. And the goal is to get a decent result window to then pass to our re-ranker. We use a tool called MetaRank. You may have heard of it, you may have used it, you may have written it. All sorts of people in the crowd. But we use the reason we like MetaRank is because it enables us to do lambda mart, which is awful. If you've ever had to run this at scale, we can just shove a bunch of data into it, click-through rate, position bias, recency, sponsored product, all of that stuff you can just jam in there. It figures out a model, and it's really, really fast too. So we take those results out of Elasticsearch, pass them through MetaRank, call it a day. The problem is that we didn't always have this search pipeline. We actually used to use another vendor. It rhymes with Schmalgolia, but I won't put their business on the street. Anyway, when we moved from Schmalgolia to this Elasticsearch pipeline, it was super easy to know, like, with the new pipeline, did we more or less get the same products that Schmalgolia returns? If so, we're looking good. If we miss some, keep on working. That was our golden set. But after we moved away from Schmalgolia, messy breakup, we then had to sort of build our own way to improve it. And so this is where the need for a golden set came from. So we're not going to build a golden set at Flink manually because who has the time? I'm sure all of your companies have well-funded teams and tons of back-end engineers available, just like ours. That's a joke because we don't. We have a back-end team of 1 for the search team. So we're not building this thing. And so why not try and delegate it off to an agent flow? This entire talk is inspired by a guy named Doug Turnbull, who you probably recognize the name. He's all over relevance blogs and stuff like that, pushing his latest course. And for better or for worse, agents, LLMs are simply not capable or fast enough to run e-commerce search at the latency that customers expect. It's simply cost prohibitive, latency prohibitive, and they error out all of the time. So for better or for worse, we have a job still. I won't say forever, but I think for at least the next couple of years, traditional search engines, traditional search training techniques are still, I believe, the golden standard for e-commerce search. But let's build an agentic thing together. So I will wager that everybody in this room has used an LLM at one point in their life. Not super risky. I will also bet that most of you have used an LLM API. I use OpenAI, I'm sorry. I don't use any fancy VLMs or anything like that, so I'm not a shill, but their SDK is oh so good. So most of the time when you're working with the LLM API, you specify the model, you specify your input, and then it will give you an output. Text in, text out. It's been like this since GPT 3.5. Most people can just like ask it questions and then get the response back. What we typically would try and do is we try and get it to build into production systems. And to do that, you need OpenAI to return structured data. And this has always been really challenging because what you have to do in your prompt is you have to say, hey, I want you to do this thing, but also return it in JSON, pretty please. And sometimes it would, and sometimes it wouldn't if it didn't feel like it. You had to have a lot of parsing to get the weird Unicode characters that it would inject in there. It was a nightmare. So around GPT 4.0, they introduced a new feature, which is called a function. This is not a particularly like revolutionary thing. I completely missed it. But this effectively unlocked the ability to build agentic systems. So in this example, what we can do is we can pass to the model and we can say, what is the weather in Berlin? And then you can give it a tool. And that tool will have a name, it will have a description, so the LLM knows what it does. And you can also exactly specify how it should respond to you, what parameters you will accept back. And you can see that in this description. The last thing is you can say tool choice is required. What this means is that OpenAI cannot respond to you with text anymore. It can only pick a tool. And so what the tool might return is it might say it's complete, and the output is function call, get weather, and the arguments will be location : Berlin. So it just took that sort of text input that you gave it. It was able to extract the city. Hey, that's really cool. But let's make it a little bit more interesting for search. What if we had multiple tools? So what if we have a more difficult query like, should I wear a rain jacket? This requires the LLM to ask what the weather is outside, and then it can tell you. So the way that you would do it is you would give it access to both tools, both the get weather tool and the record decision tool. Again, you put that magic word at the end, which is tool choice required. It has to pick one. So it will say, okay, let's get the weather. And then what we do is we return back. When we're calling the API back again, we pass back basically the data of the response. The LLM doesn't care where you got the weather from, whether you have an API, whether you check the window, doesn't matter. So what you do is you pass back the weather to the LLM, and then it will decide what to do next. One thing that you can also do is you can append additional messages to the weather. You can say, here's the results of your tool call. Also, by the way, we'll get into that, how we can use that later. And then the last thing the LLM will decide, it will say, okay, I know that it's raining outside, therefore I will call another function and we will record the decision that, yes, you should wear a rain jacket. So congratulations, we've just built an agent, something that is able to explore the tools, explore your data, and make a judgment call on it. But let's make this actually relevant to search. So let's give it a different kind of prompt. You are a search relevance expert, and you are going to create a golden set for the query milk. The steps are, you can call list categories to get an idea of what categories I have in my catalog. Run multiple diverse searches. I don't tell it which ones. I let the LLM decide. Like dealer's choice. Of those products, call browse category to see if there's any products that you might have missed in your search. And then once you have seen all these products, I want you to judge each of these products with the record judgment. I give it the scoring guidelines. I tell it how I expect it to judge. And then I give it access to all of the tools that are available to it. So it might have access to the list categories tool, the search products tool, browse category, record judgment, and so on. So as you're talking to the LLM, it will be loading all of these messages one after the other in the LLM context. So typically when you're doing these sort of like multi-prompts, talking to it, it returns, you talk back to it, you have to include the previous prompt with the next API call. And you might think that by having the LLM go through your catalog and at the end of all of this stuff to be able to say, okay, ChatGPT, tell me which products you judged as 2. It will probably not be able to do this. And this is because of a well-documented phenomenon, which is called lost in the middle. That is to say that most LLMs are trained to read the context, but it pays extra special attention to the beginning and the end of the context. The stuff in the middle, it will forget, it will lose it. And this is true across most high context models, whether it's 3.5, 4, Opus, all of them suffer from this lost in the middle problem. So the solution that I would propose is to bring in this concept of tracking state. So the LLM is really good at exploring things. It's really good at like discovering your catalog, looking at the products and evaluating them yes or no. It's not good at remembering. It's also not good at not hallucinating. It's also not good at just like randomly aborting and saying, we're done here. And so you, the developer, have to write a small framework around the LLM. That's what the agentic flow is. When you're talking about Claude code or something like that, they call this the orchestrator. The orchestrator is in charge of driving these sort of sub-agents and making sure that they complete the tasks that they set out to complete. So the agent state in this particular example might be something like counting iterations. So I'm sure that all of you have lots of budget in your OpenAI bills. We don't. So we typically would want to always set an iteration budget to say, you can explore this catalog, but you have 20 tries. Search products, browse categories, those all count as 1 try. Go. And so as long as you are keeping track of the iteration, the LLM doesn't have to. The number of searches that were executed, what they searched for, what categories they browsed. Again, keep track of that outside of the LLM. It shouldn't have to remember. Product scene, judgments, and this information that you store in the state outside of the LLM is super useful for building future prompts that you're going to use with the LLM, or possibly guardrails to make sure the LLM doesn't go off course. And maybe at the very end when it says, okay, I think we're done here, to be able to store all of this state into a file that can then be like, that's actually readable and relevant to you. So the last thing that I want to propose before we get into actually building this thing is something called guardrails. So LLMs go constantly haywire. They decide randomly that they don't feel like doing this category, that they might rank everything as 1, they might rank everything as 5. And so guardrails allow you to declare rules that that the LLM might not know. For example, the iteration budget. Let's say that you only want to allow 20 searches or browses to your catalog. You don't have to tell the LLM what their budget is. You just have to tell the LLM that you are counting the iterations. When the LLM starts getting close to the limit, you can take the prompt that you return to the LLM and say, hey, by the way, you have 5 iterations left. Now you have 4 iterations left. By passing this feedback to the LLM, it is actually able to hurry up. It will get this signal and it will say, oh man, 4 iterations. Well, in that case, I should do this, and then we'll be done here. So by giving this feedback to the LLM, instead of just cutting it off at 20 and saying, you're done, you can provide soft feedback to the LLM and you can tell it, hey, just so you know, we're almost done here, so wrap up. There's also ways that you can pass responses to the LLM, which is, let's say it returns something illegal. Let's say that it says, I'm finished here, but it hasn't even started browsing your categories. It hasn't even looked at the searches. It just saw one product, like, one and done, I'm out of here. You can say, no, you're not. You have to keep on going. By returning this error back to the LLM, it still has the context in memory. It still knows what its assignment was, and it just tried to do the finish command. You told it no, it will then try and browse more categories. So I view this as very different from like a for loop, because that's kind of what this is, right? You say, okay, we're going to do the golden set. Come up with categories, come up with searches, we'll go through each of them, and at the end of it all, we'll just sort of aggregate it all together. But the way that an LLM works is it's self-healing. Let's say they search for a category that doesn't exist. Let's say that they, they go way over and they overestimate all of the judgments. The guardrails basically allow you to keep this thing in check. So using these two things is actually very effective with how flaky LLMs are in general. So the simple agentic loop that we have, and I would encourage you to always start simple. Because like the moment you start getting into multi-phase stuff, it gets really nasty really fast. You present the prompt to the LLM. The LLM is given a bunch of tools that it can execute. You execute the tools. Let's say that they say list categories. You go talk to your category service, get the categories. Let's say they do search products. You go talk to the search service. You get the search products for them. The LLM doesn't care about any of that stuff. So you execute the tool, and then you update the state. You say, the LLM just searched for X. They increased their iteration count by 1, or they just browsed this particular category. You also want to check the guardrails. Make sure that what they did was legal, what they did was valid. And if all of that stuff passes, you then give the tool results back to the LLM, and you can also give it additional prompts. You can say, okay, you're getting close to the iteration limit, just so you know. So using these two things, this is a very simple agentic loop, and the context will continue to accumulate and accumulate and accumulate, and eventually you will probably hit the GPT nano context limit, which is 400,000 tokens. Sounds like a lot. It's 1,000 pages of single space text, but product data is huge and noisy and full of garbage, and so you will almost definitely hit that token limit if you try and hold your entire catalog in one LLM context. So if you're feeling up for it, you can do a more advanced agentic loop. So the advanced agentic loop is what I call the poor man's Claude code. So the way that Claude code works is the first thing that it will do when you give it a task like update this unit test to, fix this unit test or something like that, it will do shallow exploration on what it has to do. It will look at some files, it will check out the class, and then it will come up with a plan. It will say, okay, the user wants me to fix this unit test. These are the things that I have to do. Boom, 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 boom. It will create a list of to-dos. Once you have this list of to-dos, you can then go to the execution phase. The point of the execution phase is that you can execute these commands in what's called sub-agents. So something that you're going to have to be very careful with is context pollution. You have your orchestrator, which has all of the context inside of it, and then you want to spin off these smaller sub-agents so that they only do exactly what they're meant to do. I'll give an example. When I were to say, judge these 25 products and tell me if they're relevant or not, it doesn't matter if it's from a search query, from a browse query, you're just telling this sub-agent, judge these products this way. And that little sub-agent will return back a response. You update the state, and you can distribute this task to like 10, 20, 30, however many processes you want to start at the same time. And so this way you can sort of like break the problem down into smaller sub-agents. It can return back, and then you keep track of the state. The last one is validation. And this is the part that I would really, really recommend you add if you are going to go with an agentic flow. Agents and LLMs in general are terrible at being creative, the most uncreative things on earth, because they're trained on things we've already built. So what they're really good at, though, is nitpicking. So if you were to tell an agent to go be creative and go like write a song, and then you were to tell another agent, hey, critique this song, tell me what's wrong with it. The second agent is way better at it because it knows exactly how to pick and dissect it. And so what I would recommend if ever you're building an agentic flow is to do your discovery phase, to try and use guardrails and guide the sub-agents as best as you can, but then always run a second validation step with another model, whether it's another model with a different context, but always give them the exact same data and say, you just told me these 25 products were relevant. How do you feel about those right now? Do you want to change your answer? And more often than not, it will bump some up and it will say, I don't even know what I was thinking there. Like this is not even relevant at all. And so this is how you can basically create these nice feedback loops. Using guardrails, you can even like jump from phase to phase. So for example, if you have a restriction that you must get at least 50 judgments, you can basically like it gets all the way to the end and you could say, you don't have 50. It will go all the way back to the plan phase and start another plan and do it again. This is more or less how Claude Code works, except Claude Code was built by much smarter people than I was. So, and mine was mostly vibe coded. So bear that in mind. But anyways, I promise we'll get to questions at the end, but I just want to share some tips and lessons that I've learned. And I'm going to turn this agent into a human because I personally failed the Turing test all of the time. I'm constantly cursing out my agent, calling it an idiot, and just getting all my frustration out. So I tend to humanize my agents. And the first lesson that I've learned is that agents are very lazy. So one bright idea I had when I was telling agents about the categories is I was like, it might be helpful for the agents to know how many products are in this category. So I attached a little like parentheses, 67, 220, 660. And what did the agent do? But it would always pick the smallest category. It would always do the least amount of work. It would see like, I would say, I want you to figure out rooster wall art. And it would go into like the tiniest category ever and say, I've explored it and I found one product. We're done here. And so so you have to be very careful with the amount of information that you give to an LLM, because an LLM without explicit constraints will always try and do the task in the smallest amount of work possible. If you tell it how many products there are, it will almost always gravitate towards the least amount of work, not what the actual job is. And this is where we come back to like building sub-agents where it doesn't need to know if it's a search, if it's a browse, just tell it what to do. The second lesson I learned is agents have ADHD. So in my training set, I had a category that was like 600-700 products, and it was called wall decor. And at Wayfair, a lot of the products all sound the same after a while. So what I noticed is the agent would get to like position 300, and it was like, I've had enough of this. I have enough roosters to like last me a lifetime. We're done with the wall decor. And it would stop paginating because it felt that it had discovered enough of the category. And this is also an LLM thing, which is that LLMs are trained to not necessarily seek every single fact out there. It's trained to basically retrieve a couple of facts and then say, I think I have a good idea of how to answer this question. So by design, LLMs will always not explore things all the way once it feels confident that it can answer the problem. But that's not what we wanted it to do. We wanted it to browse the whole damn category. And so you have to make it, you have to force it. You can do this by spinning off separate subtasks and so on. One other thing that I learned is that rules equals the bare minimum. And this is another thing that agents do, which is super annoying. If you say you have to generate at least you have to run this at least 3 times, you have to search at least 2 times, it will do exactly that and no more. And that's another problem with LLMs, is they're designed to focus on the numbers inside your query. They don't necessarily handle it like a human would handle it, which is to say, search for at least 3, search at least 3 products. Humans would say, that could be 3, could be 5, could be 10. The LLM will almost always opt for 3 and then call it quits. When I was designing my agentic flow, I had this thing where I said, you must issue 2 searches. And the agent had only issued 1 search. And so I had a guardrail, and the guardrail said, you did not search twice. It searched the same thing twice. So it searched for milk, and then it searched for milk again, like a petulant child. It was just like, fine, I'll search for it again. Yep, looks good. It was incredibly frustrating to deal with this thing, which was very smart, smarter than I am. And I've constantly felt myself fighting against the way this thing was designed. And then, as everything goes, the 80-20 of vibe coding. You're going to get this thing up and running in an hour. I'm going to include a code example, and you can take it and use it, and it will take you like maybe 30 minutes, 40 minutes, probably with an agent, to adapt to your use case. But you will spend the next, what feels like an eternity, stopping it from finding every single blind spot in your prompts, stopping it from hallucinating, wrong formatting, ignoring the context, ignoring the instructions. This is where a lot of the effort goes into it. The framework is super easy to build, but the prompt engineering, whatever they call it, context engineering, that part does take a long time. And if you have a fundamental understanding of how LLMs work, you'll get a whole lot further. The last thing that I wanted to share is that throughout all of this, solid engineering practices and empathy were the best way to get this thing working. So LLMs are very magical, but what we can do is we can basically build an airtight container around the LLM. We can prevent its worst behaviors. For example, robust guardrails to make sure that it doesn't go off course. You can re-guide it, push it back into play, but it does require a lot of state tracking and making sure that you're doing the right things. The LLM constantly hallucinated IDs. I would give it a 25 products, it would make 50 judgments. And so I had to have this system whereby it would look at the products that I had sent it, and I would have to deduplicate all of the products that it just pulled out of its butt. So hallucination detection, deduplication, it would repeat things all of the time. So storing what it had done and then presenting it back to it to say, okay, you're on this step, you've done these steps, what's next? And you can really sort of nudge it along. The last part sounds really weird, which is to empathize with the LLM. When I was building my thing, what I noticed is that some keywords worked really well, and then sometimes it would miss the most obvious product, the most obvious product that was clearly relevant. And I must have spent a couple of hours trying to prompt engineer, move things around. Maybe I was you must do this, always, tried all of the tricks in the books. When I actually looked at what my prompt was generating, I found that in my haste of vibe coding, it had truncated the product description. Claude Code had decided that 50 characters is probably enough. Who needs more than 50 characters? And so it had truncated the product description, and therefore the LLM wasn't getting the entire context, wasn't getting all the attributes. The products that it did find were just because that description happened to be in the first 50 characters. So always test your inputs into these models. So you're building a Python framework around it, test how the browse categories works, test how the search categories works, and ask yourself, if you were given this problem, could you solve it given the information that it has? Because it will not be as good as a human. I'm here to tell you our jobs are safe, but this thing can do what takes humans months in minutes. So maybe not so safe. And then the last thing is, OpenAI, I'm not sure about other models, but OpenAI at least allows you to see the reasoning that the agent is doing. And this is really, really helpful because it will tell you what it's doing and why it thinks what it is thinking, why it's executing the search. And it's really insightful because it will tell you exactly why it is committing these specific actions. So if you combine all of these things together, the engineering practices and empathy, I think you're going to build a really good product. How does it do? So I'm very biased because I gave 10 years of my life to Wayfair. So I use the WANS dataset. If you're not familiar with it, it is an open data set from Wayfair where it gives you about 20,000 products, 222,000 human judgments, and then a bunch of queries to go with it. And it's perfect for this kind of exercise because they basically have the products, have the queries, and then they have what humans have denounced as the golden set. When I ran this on the WANS data set, I was able to catch about 80 to 90% of terms that they considered to be exact matches with my agentic flow. On the partial rating, it was a little bit sketchier. I didn't do as well. But the most important thing is that this thing ran in like 2 or 3 minutes per keyword, and it cost 5 to 10 cents in GPT-5 Nano. I'm sure your companies can afford this. So to run like 100 queries through this thing would be 10 bucks. And you can use more expensive models if you're made out of money. But I thought the GPT Nano was pretty nice. And the best part is it's infinitely parallelizable. These building golden sets, building taxonomies, all of these things are fairly independent of each other. So you can spin off like 10 concurrent threads. This is a doable task. It's something that you can calculate in a couple of hours, store that, and give it to your search team and make them very, very happy. So lastly, my boss wanted me to also put this in here. We're hiring a senior research scientist for our vehicle routing optimization problems. Not quite search, but you know, an engineering manager and a senior software engineer, which works on the search team. So we'd love to have you. I also wanted to include 3 links. So the first is the original Doug Turnbull article, where he talks about building an agentic flow in 40 lines of code. I have a GitHub that I want to share with everyone. I basically built this advanced agentic flow that does planning, execution, and validation. Take it, rip it off, make it better, please. It was really, really fun to build, and I think that it can be applied to many problems outside of search. Anything where there's just high manual labor that generally requires human judgment is a very good candidate for this sort of framework. And then if you are interested, I have a tech blog on our search infrastructure, which talks a little bit more about classifier, Elasticsearch, and MetaRank. So that's all I have for you today. Thank you for listening, and I'd be happy to take questions.
Thank you. Thank you, David. I can already see a first question.
I love your talk. So I just maybe misunderstood. Did you build the agentic framework for it, or why not use like Pydantic AI or ADK frameworks, like all the tool calls are already built for you? You can build around it, right?
Yeah, it's a really good question. And it's something that I had considered, like why not use K8s or like you said, like Pydantic, which are frameworks basically designed to do this exact task. And my answer to you is probably not super satisfying, which is that to learn a framework takes a lot of time. And these little small agentic frameworks are fairly lightweight and easy to build. I did personally like the customizability of actually building it myself for a purpose, rather than trying to mold my implementation to the limitations of a flow. But you're right, you could absolutely do most of this stuff using very smart people's frameworks as well.
Thanks. First question is, the presentation looks really nice. What did you use to make it?
It's vibe coded. It's a Vite app that Claude Code made for me. So
This
I
was
can't share the
most burning
slides.
question tonight.
Hi. First of all, compliments to you. You have definitely mastered the art of presentation.
No,
I
thank
enjoy
you.
it, even at this hour after my work hours. So I have 2 questions for you. Could be combined into one. I'm more interested to understand your, mental maybe map around evals and error analysis. something I feel like which is very connected to this, but you haven't talked about this. And from the evals as well, like, did you go towards the Likert state, something that LLMs are not supposed to be used for? I mean, my experience has been terrible with that.
I'm sorry. So I'm a backend engineer, so you're gonna have to dumb it down for me a little bit.
I meant like with the evals, if you provide in your prompts, like, oh, this is a 1, this is a 2, this is 3, 4,
I understand. Yeah,
it doesn't work
you're right.
great.
You're absolutely right.
And I was wondering, like, if this is what you have used. I mean, I was waiting until the end of the presentation that you would talk about this. So, which is why I said, like, I mean, could be combined into one, evals and error analysis, but then that's what I would love to know more about.
For sure. So you're absolutely right. So trying to get an LLM to give a gradient, I tried 4, 3, 2, 1 for my precision scores, and it would rate everything as a 4. It was just constantly like, it would say everything is super relevant, or it would say everything is irrelevant. Getting it to do these partials was extremely difficult in my experience. And what I was able to do is I built a score distribution guardrail, whereby if the agent would return back nothing but 4s or nothing but 1s, you kick it back and you say, please read the eval again and return a better diversity thing. So you can control it using your framework to basically reject all 4s or all 1s. But I had the exact same experience as you, which is that it's very bad at like figuring out shades of gray. And then as far as the error margins go, I use the WANS dataset judgment to figure out how far away I was. While I was iterating towards a solution, I would basically just try and get as close as I could to their exact values. No, I found that I think the LLM as a judge, we've tried that at Flink, and it was wildly hallucinating between different runs. It would have different opinions. We never had luck with it. And so I find that like by using an agent that can basically validate itself, I had a little better luck keeping it within the bounds.
Yeah, thank you for the amazing presentation.
My pleasure.
My question is, have you thought in like for the objective to save tokens, to save costs, to use what we learned on machine learning and stuff and replace some of the stuff the LLM could do with some algorithms? For example, the first stuff when you use classifier, you didn't change the LLM header to predict the category instead of an X token. You use XGBoost, cat boost or stuff. Maybe for the search stuff, instead of putting LLM to go to over categories, you could do a regex or something, and then just output the, just send the output of the regex to the LLM or stuff like that. Maybe the latency will be higher, but the cost will be lower. Asking.
You're 100% right. When I built this framework in like 2 weeks. When Roman approached me and asked me for a talk, I was like, oh shit, I better build a GitHub so people have it. So, but you're right. Like, I wasn't really worried about token costs. I think to do one eval, it cost about 1 million input tokens and about 400,000 output tokens with a reasoning model. That's a lot. And you're right. Like, when I listed categories, I could have been way smarter of which categories I presented to it. If you work at a company like Zalando and you have millions of products and thousands of categories, you probably want to do some pre-treatment instead of just giving it this fire hose of data like you were talking about.
Yeah, my observation was also related to your conclusion. If the agent is lazy and he doesn't want to go to all the categories, just use an algorithm that goes to all of the categories and feed the output, right?
I think tuning the token count on this thing, you could also change the amount of reasoning. So I used medium, you could probably change it to low. I think there's a lot of work that you can do, which is why I hope that like people can use the framework, this sort of like 3-phase framework, and then please do a much better job than I did to make this more cost effective and so on. But yeah, I think they're really good suggestions. Thank you.
Yeah. Thanks for the great talk, Dave. I'm curious, so let's say the agent has identified the golden set for the milk, and it turns out that the regular cow milk is the best fit. But now we're in Berlin, everyone is vegan, and turns out that the users actually prefer the oat milk. And then it turns out that the golden set is not actually that golden. So how do you go about retraining it based on that?
I mean, we don't sell to vegans, just. No, you're right. So I think that what you're talking about is I think that for most people, I will put the big error bars on this one, that we in search, we generally try to solve towards the sort of majority of people, and then we let the personalization layer happen after that. When I was building this golden set for oat milk, I would actually say that oat milk is a type of milk, and it is a partial match. So like you get points if it's in the search result set, but it's not the one that I'm necessarily looking for. And what we've also found is that I don't know many vegans who would search for milk and expect oat milk to come back. Just as humans, that's sort of how we're trained. We would expect to see oat milk. They would expect to specify it. But I think that you're right in that in terms of delighting customers, in terms of making it a much more memorable experience, the search should adapt to their dietary needs. It's something that we're trying to work on at Flink, but it's very, very challenging because, for example, we have a filter like, is this person a smoker? And then sometimes, like if I happen to buy a packet of cigarettes for my friend, now I'm getting nonstop cigarette recommendations. And so trying to infer customers' dietary preferences just from click behavior is really, really challenging and not a leap we want to make all the time.
Thank you. There's one more.
It's a bit of a wild question maybe, but have you considered just using Claude Code or Codex with a bunch of skills and a bunch of guardrails? So basically to give it tools to call APIs, store data in an SQL database, and so on, right? And just let it loose on that. My hunch is that you would get quite far, maybe 80,
I think
90%.
so.
Yeah.
Yeah, I think so. I think that the way the Claude Code license works, like we obviously know that it has like a token cap. And so once you reach that token, you're blocked, or you can pay per token. Claude is quite expensive compared to like GPT-5 Nano. And the thing that I like about GPT Nano that Claude Code cannot do is sort of like the structured tool calls. When you work with the actual SDK itself, you have much more access to like give it access to specific things. Whereas Claude Code is more of a generalist coder. You know, it's going to do its best, but it's definitely not designed for the task.
No, that's where the skills would come in, right? So the skill, you would essentially give it the recipes when I ask for this, do that.
Yeah.
And then, yeah, maybe the other related question is, have you considered using offline models to cut down on cost or,
Yes, absolutely. And I think that OpenAI, you can cut the cost in half by just submitting them in batch. I think that's a great idea.
Yeah.
Thanks. Thank you.
All right. So let's thank David again.